Alrighty guys, let me zoom in a little bit. We're going to talk a little bit more about, oh my goodness, geez, oh Pete's. We're going to talk a little bit more about solving inequalities. So we should already have like 26, 27, and 28 filled out because we did that together in class. But if you turn to page 29 and 30, I'd love to do these examples with you. So actually what I'm going to do is I'm going to zoom out so that you can see them all. And what I would recommend doing is like pausing your video now and then going through and writing all these down. You don't need to solve them yet. Just go through and write it down like I have it written down. And then once you're done copying all the problems, then hit play and you can watch me go through them all. So did you hit pause yet? Hit pause. Okay. Alrighty, guys. So the first type of problem I want to look at with you, and let me zoom back in now, is we can determine if a number is a solution to the inequality by essentially plugging it in and seeing if the inequality still holds true, still makes sense. So for instance, if I take this inequality here, 3y minus 8 is greater than 22, we're going to plug 2 in for y. So I'm going to replace it with parentheses. And basically now this becomes a question. Is 3 times 2 minus 8 bigger than 22? I don't know. I got to do a little math. So on this side, I would follow order of operations and do 3 times 2, which is 6, minus 8. And then I would do 6 minus 8, which is negative 2. And then the question is negative 2 bigger than 22? And last time I checked, it's not. I always learned it with the alligator. I know some of you learned it like differently, but the alligator mouth always wants to eat the bigger number, and the baby bird mouth always wants to eat the smaller number. And that is not happening here. Big alligator is trying to eat the smaller number. So that makes this false, or no, it is not a solution. Okay, so again, I would take this one here, plug it in. We'd have 3 times 0 minus 8. Is that greater than 22? Well, 3 times 0 is 0. Minus 8 is negative 8. And so I feel like I'm in a situation like the last one. A negative is not bigger than 22, a positive, ever. So no, not a solution. And then this next one to try, we'll plug 5 in. And then if I do 3 times 5, so 15 minus 8. 15 minus 8 is 7, and they're both positive at least, but still 7 isn't bigger than 22. So no, none of these are a solution. Okay, so another one like that, because we probably want to see an example of when we are a solution. So same problem, determine if each number is a solution to the inequality. I take my inequality, and in place of m, I'm going to put 2. And it becomes a question. Is 8 times 2 minus 6 less than or equal to 10? So 8 times 2 is 16. Minus 6 is 10. And so I'm not less, but I am equal to. And this symbol says you can be less than or you can be equal to. So since I'm equal to, yes, this is a solution. Okay, if we try number 3, and it's not like a multiple choice, guys, you're just checking all of them. So we're going to try 3 also. If I plug in 3 for m, it's a question again, like is 8 times 3 minus 6, is that less than or equal to 10? So 8 times 3 is 24. And then minus 6 is 18. Oh. And it's not equal, and it's also not less. Again, the baby bird is trying to eat the bigger number. Baby bird can't handle all that number, so no, not true, not a solution. And then let's try the negative 1. So if I take 8 and I plug in a negative 1, minus 6. Is that less than or equal to 10? I don't know. Let's find out. So we're going to do 8 times negative 1, which is negative 8. And then if I subtract 6 from that, so I'm at negative 8, I move negative 6 more. I'm at negative 14. And that is less than 10 because a negative is less than a positive. It's not equal to, but that's okay. It can be less than or equal to. And I'm less than. So yes, that's a solution. Okay, some other ones to try. Maybe I just have an inequality and I want to graph it. So when we're going to graph, we want to graph on a number line. And I'm not super picky about number lines. Like, I usually just like you to put the number that they've given you, and then at least one number that comes before it, and at least one number that comes after it. So a number that definitely comes after negative 3 is something like 5, because positive numbers are always bigger. And you can just put negative 2 because that directly comes after it, but I just like to be goofy and pick weird numbers. A number that is definitely before negative 3 would be like negative 100. That's so much smaller than negative 3, so definitely. And again, you could just put negative 4, but I like to pick fun, goofy numbers. And so on the negative 3, because x is not equal to, I put an open circle. It is not that spot. It's close to that spot. It's not that spot, though, so that's why I don't fill that circle in. And then when I compare these two numbers, because the baby bird is eating the negative 3, that means whatever x is has to be bigger because the alligator always eats the bigger number. So when I draw my arrow, I need to go towards the bigger numbers because x is going to be bigger than negative 3. And all those bigger numbers are over here by 5 and 0, and all those ones are bigger. Oh my gosh, I totally spoiled the next one. Oops. Because those graphs look the same. Whoops. Ah, well. For number 4, we want to write an inequality. So when we write our inequality, we always want to start with x and then our number, so negative 4. And in between it, I have to decide what's happening. So I know I'm not equal to because, again, it's an open circle. So I'm not going to put the little line underneath. And then because I'm going towards all these bigger numbers over here, I actually need to be the greater than symbol. So x is going to be greater, so the alligator needs to eat the bigger number. And you might be confused and thinking, like, why do these graphs look the same, but these inequalities look different? And they look different because your x's are on opposite sides. So if that happens, you have to switch the sign also, like if you change the side your x is on. So hopefully that's okay. And then we tried a few in class where we were solving as well. So just solving simple equations where we're just treating our inequality like our equal sign. So wherever I see my inequality, I put my sides. And I'm just trying to get my variable alone. So I have y minus 2. To get rid of minus 2, I need to add it. If I do it on one side, I have to do it on the other. And so negative 2 positive 2 is 0, and y comes down. 11 and 2 is 13. And so then when I go to graph it, I'm going to put 13. A number that comes before it is definitely 0. A number that comes after it is definitely 20. And because there's no line under it, I'm going to do an open circle. And because y is being eaten by the alligator, y is going to be bigger than this number. And so those bigger numbers are over to the right. Excuse me. Okay, trying number letter B. I'm going to put in my sides. Over here with x, I need it to be alone. So to get rid of plus 1, I'm going to subtract 1 on both sides. Negative 3, negative 1 is negative 4. I bring down my inequality. 1 and negative 1 is 0, so I bring down x, and x is alone. And so now I go graph. And so on my number line, I need to have negative 4. Something that definitely comes before it is negative 4.5. Ooh, decimals. Something that definitely comes after it is negative, 3.5. That's what I meant. Ooh, decimals. Don't like them, but there they are. And on negative 4, because I'm equal to this time, I can do a filled in circle. And x is closer to the baby bird, so x is going to be smaller because baby birds eat the smaller numbers. X is going to be smaller than negative 4. Now, smaller numbers are always to the left, so my arrow is going to point to the left. Okay, next, I put in my sides where I have my inequality. The thing that is happening to x is it's being divided by 5. Now, we have that special rule. If I multiply or divide by a negative, I need to flip my inequality. But because the 5 is positive, when I multiply it over, I don't need to flip my inequality. Whichever number you put on both sides is the one that matters. So because this 5 is positive, I don't need to switch it. I'm going to ignore that phone. These 5s divide out. We have x. I bring down my inequality. I keep it the same. I multiply over here for negative 10. Then I go to graph. Sorry, I know this is so annoying, but we got 2 left. I'm not going to stop. I plot my negative 10. A number that definitely comes after it is 0. Like, that's bigger. And a number that definitely came before it is like negative 20. And then on the negative 10, because I have the line under, that means I'm equal to. And because x is near the bigger side, the alligator's eating x. Alligators want bigger numbers, so I need to go towards bigger numbers, which would be towards 0. And then last but not least here, I put in my sides on my inequality. Over here where x is, I want to get x alone. It's being multiplied by negative 5. So to divide it away, when I do, because I'm bringing a negative over both sides, I need to switch that inequality. So bigger side was pointing over here. Now it's going to be pointing over there. We got to flip that inequality. Negative 30 divided by negative 5 is 6. These negative 5s divide out, and you have x left. And so then when I go to graph it, I'm going to put 6. A number that definitely came before it was 5. A number that definitely came after it was 7. See, I brought it down a notch. It was less weird. Sorry. On 6, I am not equal to, so open circle. And x is being eaten by the alligator, so x is going to be bigger than 6, and those numbers are over there towards the right. So hopefully that helps, and good luck on your assignments. Oh, assignments. Yeah. Oops. Stop. How do I stop?